All right, let's take a look at a few example problems that use the theorems about isosceles and equilateral triangles that we went over in one of the previous videos. So example 1 here gives us a couple triangles and we have to find what the x is equal to. So you can see here we have an angle that says 5x plus 9 degrees, and then we have another angle that's marked as 28 degrees. Down here we have a couple angles that use x in their measurement. Let's start with angle A. What I would want to notice about this triangle is that it is isosceles. It's got two sides that are marked congruent. Now I learned that every isosceles triangle would also have two angles that are congruent, and the angles that are congruent are the ones at the end of the base. So if here are the legs, the ones that are congruent, that makes this side down here the base of that isosceles triangle, and it means that each angle at the end of this would be congruent. So that means that I could put 28 degrees over here for this angle. Well, how is that going to help me find this, the value of x right here that involves this angle up here? Well, I need to remember that all three of these angles should now add up to 180 degrees. So for example 1, part A, I can set up an equation that says that the 28 plus the 28 plus the 5x plus 9 should all add up to 180. And then I can go through my algebra skills and I can solve this equation. So I'm going to combine some like terms here, 28, 28, and 9. Let's see, that's 56 plus 9, which would give me 65. So I'd have 65 plus 5x equals 180. And then I'm going to subtract 65 from both sides. So I'd have 5x equal to 115, and then I'll divide both sides by 5, and that'll tell me that my x is equal to, let's see, what is that? That is 23. Yeah, x equals 23. Now for part B, let's take a look at that. In this case, the two angles that they gave me information about are the base angles, right? I got an isosceles triangle again, so that means that this side is the base, and these two angles are at the end of that base, so they're the base angles, and that means that they should be equal to each other, right? So my equation that I can set up here would just say that the negative 4x plus 9 should be equal to the 8x minus 3. And then I'm going to start by solving this by getting all the x's on one side. I always say if you have x's on both sides of your equal sign, get rid of the smaller group of the x's, in which case that would be this negative 4x. So I'm going to add the 4x's to both sides so that it's gone from over here. 9 equals 12x minus 3. I'm going to add 3 to both sides. 12 equals 12x. Well, that pretty clearly means that x is equal to 1. Let's take a look at the next example. It says, find the value of x and the length of each side of the triangle. So I look at this picture, and the first thing that I'll see people do on this problem, the most common wrong answer I'll see is they'll take all of these things and they'll say they add up to 180, because they're used to things adding up to 180 when we're looking at triangles. But we have to remember that what they're giving us here are expressions that represent side lengths, not angle measures. And the angle measures are what always adds up to 180. The side lengths of a triangle, there's no magic number for what they're going to add up to. So we have to think, how can we use these clues to try and set up an equation that would let us find what x is equal to? And the clues they gave us are that these two angles are congruent. And if these two angles are congruent, that means I should have two sides of my triangle that are also congruent. And it means that this side that's across from one of my congruent angles and the side that's across from my other congruent angle, they're the ones that should be equal. They would be the legs of my isosceles triangle here. This side would be the base, right, because it's got the congruent angles at the end of it. It would be the base. Let's just go ahead and label that the base, right? This side here would be a base, and that means that this is a leg, and it means that this is a leg, and we know that the legs should be congruent. So I can set up my equation by saying that 8x minus 1 is equal to 4x plus 5. The two legs are congruent. Now I'm going to get rid of the smallest group of x's again because I have x's on both sides of the equation. So I get rid of the 4x's. All I have left is a 5 on the right side of the equation. I have 4x minus 1 on the left side. I'm going to add 1 to both sides, so 4x equals 6. And then I'm going to divide both sides by 4, and this is where it would throw some people off. They're saying, wait a minute, how come I have 1.5 here as my x? Why do I get a decimal answer? Well, that's okay. Sometimes we get decimal answers. You might want to go back through and make sure you didn't make any mistakes. Let's see, I don't see any mistakes that I made. I think I did this all right. So yeah, x just equals 1.5. So there's half my answer, finding the value of x. Now I'm going to find the length of each side of my triangle. So I'm going to plug in that 1.5 for x in each side. So 8 times 1.5 minus 1 would give me, see, 8 times 1.5 is 12. 12 minus 1 is equal to 11. So I have one side that's 11. Now theoretically, I should get the same thing when I plug in x here, right? Because I already assumed that these legs are going to be congruent. If I don't get the same thing when I plug in 1.5 here, that would definitely tell me that I did something wrong to get that value. But let's go ahead and see what happens. So I'm going to say 4 times 1.5 plus 5. 4 times 1.5 is 6. 6 plus 5 is 11. Okay, so that makes sense. I got two 11s for the legs. Now my base might not be the same, so let's just take a look. 2 times 1.5 plus 11 would be 3 plus 11, which is going to be 14. Okay, that works. And it actually even matches what the picture maybe shows me, that the base looks slightly longer than the legs. Can't always go by that because sometimes the pictures aren't drawn to scale. So I wouldn't say that's like your best method for deciding whether or not you did it right. But in this case, I feel pretty confident in those answers. Now the next problem says to find the measure of angle RSQ, that would be this angle right here, and the length of segment PR. So I got to kind of take account of what's happening in this picture. I got to wrap my head around what they're trying to show me. What are the clues trying to tell me? And so first of all, I notice that I see an isosceles triangle because segment PS and segment RS are congruent. So I say, okay, this is an isosceles triangle. One of my other clues is showing me that this vertex angle, right, the angle where the two legs are intersecting, that vertex angle has just gotten bisected by this segment. And that's the big clue, because we learned that when you bisect the vertex angle with a segment, that segment is going to go across to the base, and two things are going to happen. First of all, it's going to be perpendicular to the base. So I'm going to mark a 90-degree angle right there. And secondly, it's going to bisect the base. It's the perpendicular bisector of the base. So it's going to take that base and divide it into two parts that are the same length. And now I might see how I can answer the two parts of this question. First of all, if I want to find angle RSQ, I can actually find angle PSQ because they're the same. And I look at this small triangle right here. I look at triangle PSQ and I notice that I know two of its angles. So if I take the 31 plus the 90 plus the measure of angle PSQ, those three things together should equal 180. So combining some like terms, that would tell me that 121 plus the measure of angle PSQ would equal 180. And if I subtract 121 from both sides, then the measure of angle PSQ would be 59 degrees. But that also means that the measure of angle RSQ is 59 degrees, again, because those two angles are congruent. So there's one of my answers. I got 59 degrees right there. The other answer is to find the length of PR. Well, now I can see that if this side from Q to R is 4 units long, then from P to Q would also be 4 units long, and the length of PR would just be 4 plus 4, or 8. So there I've answered both parts, and I use that idea that the bisector of this vertex angle is going to be the perpendicular bisector of the base. Now in the next question, we have a little bit more complicated diagram here. And we have to find the measure of angle PNO. So I'm going to put a little question mark there just to identify that's one of the things I want to find. And angle NOP. So I'm going to put another question mark right here just to identify that I need to find that. So I'm going to look at this problem and I'm going to say, all right, what clues are they giving me? And the only clues I see is that a bunch of these parts are congruent to each other. These three sides are congruent, and then this side and this side are also congruent, this side and this side. You know, there's 4 parts here, 4 segments that are all the same length. Well, why is that important? Well, it means that my 2 triangles here, one of them is equilateral, and one of them is isosceles. Now, the equilateral triangle would have 60-degree angles at all of its corners, because all equilateral triangles are also equiangular, and every equiangular triangle has 3 60-degree angles in it. And then that should let me figure out this angle right there, because these two are a linear pair. They should add up to 180. So in other words, 60 degrees plus the measure of angle PNO should equal 180. So if I subtract 60 from both of those, the measure of angle PNO is 120. So let's put 120 right there, 120 degrees. Now, how is that going to help me find this? Well, remember, triangle PNO is isosceles. This is the base of it, right? These 2 sides are the legs. This would be the base. And these 2 base angles should be congruent. Let's go ahead and mark those congruent. We'll put marks on these 2 angles to show that they're congruent. Now, let's think here. If they're congruent and this angle is 120, if I take out 180, if I do 180 minus 120, I get 60 degrees. Well, 60 degrees is what I have left to split between these 2 angles. And they're congruent. So I should be able to just do 60 degrees divided by 2, get 30 degrees, and that would be the measure of angle NOP. And there I have it. I got both my angles. Now for that last one, some of you might have noticed I could do it a little bit differently. I could look at this 60-degree angle, and I could realize that is an exterior angle of my isosceles triangle. So these 2 remote interior angles, they should have a sum total of 60 degrees. And since they're both congruent, again, we would just take that 60 and divide it by 2 to get 30 that way. So that's it. We just used those 3 ideas about isosceles triangles and equilateral triangles to solve some of these example problems.